Welcome to part 2 of our lesson on continuity, day 1. So when we're working with continuity, one of the things that sometimes people ask us is they'll give you a function and then they'll say find some variables k, a, and b such that it says that, and if you notice here, it says that f of x will be continuous at that value of c. Now I'm going to be completely honest. Every single one of you can solve this in your head. But that's not what they're looking for here. They want you to use continuity. And how do I know that? Because they mentioned continuity here. Okay? So these will take a little bit of work right there. So when they say use continuity, they're talking about our rules. 1, does the value exist? 2, does the limit exist? 3, does the value equal the limit? Okay, so we're looking for all 3 of these. Okay, now we're going to keep going until we can solve. You're going to find out we don't always have to use all 3 cases. Most of the time we just have to use the first 2 because we're going to use continuity until we can solve for, in this case, k. So let's go ahead and get started here. So the first thing we have to do is check if the value exists. So let's check the value. F of 2, that's our c value. F of 2, again, we talked about this before, and then before, we look for the equal sign, that's where the value of 2 is. So we're going to use this, we're going to use the top one, and that's 2 plus 3, which is 5. Okay, did this solve for k for us? No. So then we go to step 2. We're going to check the limit. Now remember, we're saying that the limit on the left has to equal the limit on the right. But we got to nerd it up a little bit, let's use our notation. The limit as x approaches 2 from the left, space it out, equals the limit as x approaches 2 from the right. So let's see if we remember how we get the left and right hand limits. Well, we come up here. We talked about this before. If we're looking at a graph, here's at x equals 2. There's our left. There's our right. The left is to the left. The right is to the right. So we can look at our symbols. So there's our left and there's our right hand limit right here, like so. So for the left, we're going to use this x plus 3. For the right, we're going to use this kx plus 6. Now on the left and the right, we can now just substitute. Plugging in the 2, we get 2 plus 3. Plug it in for the x. Plug the 2 in for the x here. We get k times 2 plus 6. I could solve for k now. So if I solve for k, I'm going to get 5 equals 2k plus 6, of course. And we get, again, solving that, we get the k equals negative 1/2 right there. Now, we don't have to check step 3. Because you might be wondering, why don't we check if the limit equals the value? Well, that is because if we solve for k, we force the limit to equal the value. See, we set it up that this is my value, and if this is my limit, by solving for this k, we force them to be equal to each other. So we don't have to worry about part 3 in this case. So let's take a look at one of the hardest ones. Oh my gosh, this is one you will see on test and a quiz, mainly because teachers like these. So for this one, notice we have to find a and b. A and b. So, and in Algebra 2, you learned if you have 2 unknowns, you need 2 equations. Oh, yuck. So this is going to be a system we have to create. So we have to create a system of equations. So where do we get our systems from? We get our systems from our c values. But over here, we're actually going to have 2 c values. So a c value basically for this type of problem is occurs if there is going to be a place where it's not continuous, it's going to be at one of the connectors. For example, here, the first 2 functions meet at -1. We want to guarantee that it's continuous at -1. So my first c value is -1. And I find the value, step 1, I'm going to find the value at -1. So which one do we plug it into? Of course, the top. Now you should be good at this one. This is a times -1 plus 3, or -a plus 3. 2, I'm going to look at the limits of that. So I'm going to take a little shortcut here. The limit as x approaches -1 from the left, leave a bit of a space. the limit as x approaches -1 from the right. Now again, on the left, you're looking for that less than symbol at -1. That's going to be the ax plus 3. The right is going to be this one. Even though this is like negative, even though this says like -1 is less than x, switch it around, right? This is x is greater than -1. So that's my right-hand limit, is this x plus b. And if I solve this, I'm plugging the -1. We get negative a plus 3. Remember, we're subbing in for x equal to, sub in for x, -1 plus b. And if I do this, bring this over, we would get, what is that? A plus b equals, what's that? 4. So there is my first equation. Now note, again, we have two variables, which means we need another equation. So we need another equation here. Yuck. So we need another c value. Well, where do we get that? Well, to look at the second two equations, they connect at 3. So there's my other c value, and I'm going to do the same thing. This isn't that hard to do, but it is kind of lengthy. Now, so when we show this, ready, step 1, we look at the value at 3, and that's going to be, the value is the bottom one right here this time, so it's going to become 3 times 3a minus b, or 9a minus b. 2, looking at the limit as x approaches 3 from the left equals the limit as x approaches 3 from the right. Now you do need to include the values here, even though we're not using the values necessarily to help us solve it, but you have to guarantee it has a value. So you need to have that. That's actually a step that's needed. And I'm going to tell you how I would grade this in just a moment. So from the left, you're looking for that less than symbol. That's going to be here. X is less than 3. So that's our x plus b. And on the right, it's going to be the bottom one. That's this 3xa minus b. And if I sub in for the x's, 3 plus b equals 9a minus b right there. Okay, solving this one, we would get 9a minus 2b equal to 3. And there's your second equation. And now we would just solve this system. Okay, so we would have a plus b equals 4, 9a minus 2b equals 3, and I know you guys can solve this, substitution, elimination, whichever choice you want to make, and what you wind up with is a is 1, b is 3. There's your final answer. And these will force it to be continuous. Much longer question. Now note, it didn't take me too long, but I worked continuously. But let me show you how I would grade this for my own students. This is a lot of points right here. Are you ready? Showing the values are 1 point. Showing the limit steps, also 1 point. So already you have 4 points, and you don't even have the answer done. So you have 4 points, and you're not even close to the answer just yet, okay? Now, you get one, I would give 1 point for each simplified equation. So you got 6 points here. 1 point for setting up your system, and 1 point for your answer. So this will be 1, 2, 3, 4, 5, 6, 7, 8 points. On my test or quizzes, that's worth 8 points. That is a lot of points right there. And but you're showing your calculus, and you're showing understanding. And this is how the AP grades. They want to show, do you know continuity? Find the value. Do you know that you have to find the limits and set them of each side and set them equal to each other? Do you know to get your equations? And do you know how to solve it? Notice, how many points is the answer worth? Only 1 point. So if you only have the answer, you only get 1 point. Now some of you guys are really good. Some of you guys will just write this down. I got my system and solve it. But you only get 2 out of 8 points for that. So you really need to show your work on these. Alright, last one. Number 3. Oh no! So first thing first, I noticed it has equal sign and a not equal sign. So we're going to talk a little bit about that in just a second. Just get started. Let's get it started in here, right? So to find the limit, we want f of, our c value is k, f of k. Well, that is where it's equal to something, and that is the value of k itself. This is the equal sign, that is a value. At k, it is 4. step 2, whoops, oh, that's the value. I wrote down, don't tell anybody I wrote that. There we go, it should have been value. Sorry about that. Some of you guys are probably confused. To get the limit as x approaches k, well, now we have to find out, well, which one is the k? Which one is when we're not on k, where we're approaching, right? To get that limit, right? Let me write it this way. So that's this one right here, that not equal to sign. That's the limit. But let's take a look at y. If I'm at k, I know my value is 4. Anywhere that is not k, that doesn't equal it. So this is my limit. So the limit is not equal to k. It's everything else, in other words. So, and since there is no left or right, we can just take a limit. It's not like it was before where there is no left or right. So I can just say the limit as x approaches k of x squared minus k squared over x minus k. Now, really weird, if I plug in the k, I get 0 on bottom. So we have to use our factor method for this one. We get the limit as x approaches k. The top is a difference of squares. The bottom is a difference of squares over x minus k. Those cancel. We're left with the limit as x approaches k of x plus k. And if I plug it in, we get 2k. But we're not done yet. Now this is the problem with this one. See, we're not done. See, up here we have a equals, b equals. Up here, k equals. Down here we don't have k equals something. So this is a special one. This is the one where we actually have to go to the third step. Where does the value equal the limit? So in other words, where does the value 4 equal 2k? That's easy. K is 2. Now I solved it. How many points would this be worth? 1 point for the value. You probably get 2 to 3 points for taking the limit, depending on how hard it is. 1 point for your equation, 1 point for your answer. Look at that, 1, 2, 3, 4, 5, maybe 6 points right here. The point is, show your work on these, okay? You guys are going to do awesome on this, okay? All right, I'll see you guys later. You guys have a good day.